زوم. اوكي، بدنا نشرح ال OS project report بتاعنا. آه، اي بارت 1. تفضل زد.
Uh, the first part is شو اسمه Stack Overflow. Mm. The first step is we disable the ASLR using the following command. بعدين
we can see the
بعدين
output
to
is 0
find
معناته
أيوة
انه طفى.
آه. بعدين to find the address of the restricted function we use the following command highlighted in yellow. After that we open GDB. We set disassembly flavor enter. Mm.
We run the
أي-
command
أيوة.
and we see there are two inputs.
Mm. And then we disassemble the main function. Mm. Now we know that there are two possible vulnerable functions at these following addresses اللي هما get name و get favorite car.
The vulnerabilities exist because they have improper input validation. So we can overflow the input field and overflow the stack buffer. The return address can be overwritten.
Now to exploit, we need to insert a secret function address into the EIB. We're, we already know the address of the secret function, which is the following address. And since we are using an Intel-based processor, we will write it in Little Endian format. Now this is the script, a Python script, and we determine the number of A's to enter through trial and error.
As you can see, we have access to the secret function here. Part 2,
We then write the shell code using NASM.
this is our
طبعا it's
shellcode.
written in assembly, and it prints out our names and our student IDs. طبعا we used XORs to avoid null bytes.
We use these commands. The first one
Mhm.
is to assemble the shellcode into an object file, an alpha object file. Then the second one to make it a 32-bit executable shellcode.
أيوة. This following instruction, it turns it into a text file written in opcode, يعني in little endian format. طبعا after counting we found that the shellcode is 76 bytes. We have 503 bytes for the EIB. After calculating, we need 427 no operations and 76 bytes for the shellcode. Now we need to find the return address, which is at the beginning of the ESP.
We did disassemble main here to understand it a bit more with a break before the printf statement.
So to find the address for the beginning of the ESP pointer, we need to set a breakpoint for printf and overflow the program. After overflowing, reaching the breakpoint, we need to use
Command here.
this command to find the address.
The beginning here starts at this address. As you can see, the first 0x41 is at the third byte. So we will
Yeah.
take the next address for the return address. And then we need the 427 no operations, and the shellcode 76 bytes, and the return address
Mm.
in Little Endian.
This is the full Python script. It includes the number of no operations and the shellcode itself and the return address at the end. Oh, this is after executing. As you can see, this is the output. It did what it's supposed to do, and it printed out our names and our student IDs.
For part two, we wrote a C vulnerable program. The vulnerability here is the string copy function. The string copy function doesn't do boundary checking, so invulnerable, so it causes a buffer overflow. We compiled it into an executable file, and
We
we
turned off the
disabled
stack protector
we
and
dis
we disabled the ASLR.
yeah, we disabled Canary and the ASLR. We gave it ownership. We changed ownership to root. We gave it SUID. All these steps are done to get root permission when executing the return to libc function. Also here we used trial and error. We found out we need 66 bytes to overwrite the EIP. And now we need to find the address of the system, exit, and the bin/sh. So we did gdb vuln, and we ran the Python script here with the 66 bytes. We set a breakpoint at main. We find this address. And now we extract the addresses using print system. And this is the system address. Print exit, this is the exit address. And to find bin/sh address, we need to look for we do iproc map first. And we need to look for the first lib offset object file. And we take the start address and the end address. So we do find start address, and then comma end address, comma bin/sh in quotations. And we'd find one pattern, which is the bin/sh address. Converting them all into Little Endian, we have the full Python script in this order: 62 bytes of A, the address of system EIP, address of exit, address of bin/sh. 62 bytes of A, system and exit, and bin/sh. Once we compile that, we can see once we ran the whoami command, we get Ubuntu, which means we have gained root access successfully. For part 3, we have to just repeat the same steps, but for ls in our case, instead of bin/sh. So the system and exit addresses were the same. And once we do iproc map, again for lib, we get the first address, second address, and we find it with comma in quotation ls. We get 4 addresses here. For these 4 addresses, we pick one of them, we pick the first, and we run the same Python script in the same order: system, exit, and the ls address. And we can see here that the ls command has run successfully. That's it, the project.